I like your response even more now.
Cool. Like, never mind. I guess we're just not.
Oh man, I just. Yeah, she.
You can go ahead and unplug this. This is not.
Okay.
I'm just like getting started.
Right, like something. What
Is
can
no
I do?
one working? Is no one innovating right now?
Apparently not. This is a non-innovative space today.
Yeah, I was sort of like walking. Like I got here and I was like, really? No one's working.
I'm surprised Carolyn line at least an email or text saying, "Hey." Yeah. Okay.
Oh, people can hear us.
Oh. You hear a? Oh yeah. You've got the broadcast going.
Yeah, I mean, I was just like, let's get it started,
Nice.
right? Like,
Let's get it started.
but.
Yeah, you can mute. Surprised
No, that's. I'm ready. Oh, you can see into the camera on his fancy Nikon. Yeah, you can see through the aperture. It's kind of crazy. You're seeing through the lens. It's disconcerting in many ways. All right, hey guys, it's 6:30, so we're gonna get the presentation phase. So okay, fun time's over. Mandatory, now we have to do the real thing. I want to make a couple announcements, and then we'll get right into it. Oh, there's YouTube playing in the back. By the way, YouTube is playing in the background, Carl. We are still very much working out some AV kinks.
We're still
are we good? So I think welcome to Silicon Swamp. We got some more people coming in. Great, join us. We have extra chairs if you guys need them. If we don't have enough for you, or you want your own space. But thank you. Thanks for joining us. So this is Silicon Swamp. This is our weekly-ish meeting. Every third Thursday, there will actually be an art and tech thing going on here. So Silicon Swamp will happen, just won't be our event. So feel free to come commune with your local tech. And there's alcohol. For those of you over 21, there's free beer and wine. So it's in its own right, pretty cool event. This is Silicon Swamp. We're just getting. This is our second week of it, so I appreciate everybody showing up. We have new faces even from last week. We have a better turnout, so we're growing. I'm really happy to see everybody. If you haven't been here before, which means you didn't come last week, the format that we have going for this right now is that we have a speaker come each week. I do a short, or Carl does a short little interview, and then they present something on a technical topic, right? So what we have focused on for this is technical talks that are non-introductory in nature. But we're open to any sort of suggestions. Let me or Carl or Chuck, who's also an organizer, or Lucia, no, I struggle with this. Lucia, no, all feedback is welcome. If you haven't already, not only can you sign up on the Luma events, but we also have a Discord, so you can interact with us and all your fellow Columbia, Midlands Tech brethren and sisters and groups of people all are there. So feel free to join us on Discord. And yeah, if you're interested in speaking, reach out to me and or Carl, and we will get you on the list. And so yeah, that's it. I was asked to smash that like button, subscribe and follow, thumbs up on LinkedIn, hearts on Instagram. Spicy memes are all on Instagram, by the way. We have a whole little collection of spicy memes coming out for our tech scene.
And there's Discord.
And there's a Discord. So the Discord, I don't know what you do on Discord. Emoji on Discord, whatever it is. But join the Discord. We have, I think, 12 people on the Discord. So we're growing that. We're going to put bots on it. It's going to be cool. I think the only thing I was asked a little bit about the name, and I do want to clarify, we are an apolitical organization. So we had not thought that there was a political context so much, but there were some people. But I will tell you, the name was sort of a tongue-in-cheek poke at the number of people that have a silicon, and then they pick the nicest geological feature that they could in their area. So I think the Nebraska is trying to be Silicon Prairie. Charleston is got Silicon Harbor. Venice Beach, California is Silicon Beach. I thought it would be fun if we were Silicon Swamp. And so I think we very much have a vibrant tech community here in South Carolina. It's not a community you get to see a lot. And I think we hope that this event becomes the nexus of, hey, you meet somebody who's in tech or interested in tech. Where do we find other like-minded technical people? Go to the swamp. So we hope to be here for many months, weeks, years. And that's it. That's our little thing. Are there any questions before I dive in? No, great, cool. I explained it perfectly, just like always. So yeah, Lucia will be joining us today. I apologize. Lucia will be joining us today. She's giving us a presentation. Lucia, it's great to have you.
Yeah, thanks for having me. And it's cool to have something like this organized in South Carolina, Columbia.
Right here in the Midlands. Right. So you are not originally from here.
That's right. So I'm from Central Europe, was born in Czechoslovakia, which is no longer a country because we got a divorce from Slovakia, so it's now just the Czech Republic. And we definitely beat them. We're better than them at hockey at this point, so we're definitely better. They made a poor choice, but maybe they'll like join us up again at some point.
Just for the hockey.
Yes, that's my dream one day, that we'll remarry and then we'll have a even better hockey team than we already have. So we're the world champions of hockey, in case you all don't know. We're very
good. Czech Republic, world champions at hockey.
Yeah.
Everybody, you have to know, in America, we're all pretty excited with how good we're doing at cricket these days. That's like the big news in sports, is like we beat a team at cricket. We beat Pakistan and we lost our minds. So we haven't had time to go circle back to hockey and other sports. We're pretty impressed with ourselves.
It's hard to play hockey in the swamp.
It is hard to play hockey here in South Carolina, but we used to have one in Columbia.
Swamp rabbits in Greenville.
We used to have the Columbia Inferno, which is completely not a great name for a hockey team. Like fire, but that was fun. I used to go to those games in high school. We had a little minor league hockey team, so it's a surprising amount of hockey. More the fact that it existed at all was surprising. So how did you? You're obviously in tech. I think you have a degree in computer science, right?
That's right. I went to USC and got a computer science degree back many years ago.
Oh, what made you want to get into tech and specifically software?
So growing up in the Czech Republic, I was definitely convinced I was going to be a lawyer. And then I changed my mind. I didn't want to be a lawyer. And I was totally going to go into political science. And I got into the competitive program in the Czech Republic, was going to study political science. And then I ended up moving here. And I decided I didn't want to do any of that here. So I just looked through all the majors and I was like, what do I want to study? And it just so happened that from a young age, I started playing on the Atari as a kid. And I was always doing artsy stuff. So at one point, I remember that I started, a friend showed me this program and you had to type in words. And I had started learning English in second grade, so I could type words like draw, and then you would write like parentheses and then some numbers, and I realized I could draw things when I run the program, and I had no idea what I was doing. I would just like try different things, and I would draw like houses and circles and things like that, and I had no idea what I was doing. And then I graduated to Paint, Microsoft Paint. And then in high school, had to take like a computer class, and that's where we started learning basic programming with the language BASIC. And I realized that that's what I was doing back at 11, 12, and when I had no idea what I was doing. And so I've just always been doing stuff like that. And so then when I was deciding what am I going to do, I said, well, that seems like something that I know a little bit about. So that's what I studied.
And that's it. Now you're like stuck. That's your life now. You've had like an interesting professional career, right? Because you've worked in tech for a while, and I think you're actually have been for a while a product manager, right?
Yeah, so while I was at the university, I worked at a local startup as an intern, and then went and worked as a software engineer at a Fortune 500 company that was in town back then, and then went and worked for a different startup as a software engineer. And then I did switch a little bit to work as a product manager, where I was working with software engineers and defining what product features we would implement and what would the features do. So that was a high-tech, high-growth product. And now I'm doing more entrepreneurial stuff.
What are you doing now? Yeah, that was literally my next question. And what are you up to today?
So we do a lot of document processing and expediting document processing using AI, simplifying how people can work with documents, which can include automatically classifying documents, automatically detecting that a document is an invoice or another type of document, and then based on the type of document it is, automatically getting information out of the document to make it simpler for the worker to enter data into another system. So,
And you're doing that with Avalanto, or what's the entrepreneurial group that you're doing that with? Or is it Stealth? Or does it have a name?
it has a name, but it's not that important.
Okay, great, fantastic advertising. Is that the actual name? Like, not that important LLC.
Yeah.
So you work with Chuck, who's also one of our organizers as well, right?
That's right.
Mr. Wilson. So no, I think it's cool because, again, I don't think people realize that. I think you're in an interesting space, both that you're here in Colombia, you're working with a serial entrepreneur and my personal mentor for all business things, Chuck, but you're also, I think you're in an interesting space in the B2B, right? I think when we think about tech, a lot of times we think about apps like Uber, and they're very consumer, B2C, consumer-centric, but you're actually in a very vibrant space, much like my startup, in B2B, right? And how do you like that?
That's right. My career has always been B2B, and I didn't necessarily, it just sort of happened that way naturally. So I worked on like backup software or networking software, IPv6, or then I worked in the contact center space. And so I think it's interesting because you can reach a lot of different people, and it's also challenging in the way that you get feedback sometimes, where your ultimate customers are somebody else, and then you have to really take into account all sorts of industries and all sorts of users. It's very broad. And so I like and appreciate being able to understand the very complex space. So if you're working on a software that's very, very specific and narrow, it can be challenging in different ways. But let's say some of the software I worked on was used for nonprofits and was used for, let's say, the National Domestic Violence Hotline on one hand, which is a nonprofit organization. And certainly you want the software to work for that kind of software that appreciates anonymity and is helping people be safe. And on the other hand, there's the for-profit software where you have software such as Adobe, who's trying to make money, and they have conflicting interests sometimes. So how do you balance that in a way that you don't necessarily hurt the nonprofit software that's trying to help people, but also provide value for the people who are creating software for profit?
Sweet. All right. You've got a wonderful presentation for us today. You're going to talk about model evaluation.
That's right.
In the AI sense, not in the like actual like modeling sense. I'm hoping I don't see like a bunch of people just leave, right? Like, oh, this is not what I thought. Oh, lame. No, I think we've got the right crowd for today. I'm excited to see it. I think you were telling me that you're probably like one of the best in the world at this. Like you. No, but I think it's going to be a great talk. You've got the slides up. I'll let you introduce it and talk about it.
Okay.
Are you, before we dive in though, are you a hold questions to the end person, or if people have a questions, do you like the interaction a little bit?
If anybody has a question, feel free to ask.
Okay,
during
great.
the presentation.
I just didn't. If you were like, I like my flow, I want to like go through it and crush it. So great. If you have any questions, you guys can feel free to shout them out. I'll repeat them on my mic so that people know. And I'll also monitor the chat, which, because we have this vibrant live streaming community in Discord. There's 8 people. Oh, what? Actually, wow, I'm like a little shy now. Like 8 streamers. All right, if you're on the stream and you have questions, I'll be in the chat and I'll moderate some of those out. And Lucia, thank you so much. And Let's do it. Woo!
Carl is saying I have to stand.
You don't have to do anything. It's your show now. I have to remember that I have a hot mic as I'm like wandering around.
So the topic I wanted to explore with you today is how to evaluate models. And as Tad said, it's in the machine learning sense, but you can certainly take it in any way you can. So there's always potential double meaning for any word people use, so based on what you know. And so when I think about evaluating models, you sort of have to be able to prove that something works the way you say it does. So that's something I wanted to explore. So once upon a time, I started with this question. And as you may know, when you have a wondering question, sometimes you think you're asking a pretty simple question, but once you start diving deeper into it, you realize there's a lot more to it, and you uncover all sorts of things you didn't necessarily expect to uncover. So I started with the question, how can I prove a model works well? And if you want to go down this path with me, I can share with you how I went through it and what I found out and what I learned, and hopefully it will inspire you to maybe ask your own questions and answer them, and maybe you'll come and present on what you found based on all that you learned along the way. So once I got down that path, I realized maybe I want to narrow it down a little bit, because proving all models work well can be a pretty broad topic. So maybe let's narrow it down to just classification and classification models. So in order to do that, we're going to have to answer the question, what is a classification? In the regular world, as humans, we classify things all the time. So, and you've learned it as a kid. This is a chair, this is a table, and that would be classes of documents, and you determine that based on the features of it. So the chair, you can sit on it. It has a back. Some chairs don't have a back, but you can still recognize it as a chair. A table, it stands on something. You can put stuff on top of it. And really, in machine learning, it's very similar. It's just you're teaching a computer how to do it. And so it's as if you were teaching a child how to do it, but there's a lot of different techniques on how you would teach a computer how to perform these tasks. So imagine it's as if you were teaching a newborn how to do things, or a little kid. So some of the examples that you may recognize for classification are email spam detection. Is this email a spam or not? So in order for the email to get into your spam folder, somebody has to go in and classify that this email is spam. And typically it's not a person doing it, but based on the characteristics of the email, and there's all sorts of things that go into it based on the DKIM and all sorts of things people determine. Based on the sender, people may determine through a classification model whether the email is a spam or not. You can also, as we talked about, do document classification. Is this a birth certificate or is this an invoice? And classify documents like that. And then a simple example for image recognition could be the Seek app by iNaturalist, that you can download. It's free on your phone, and you can identify plants, keeping in with the swamp theme, where you can go into the swamp and identify all sorts of plants that maybe you didn't know the names of. And so ultimately, on the software that's using, it's essentially doing classification. And then I just wanted to touch on the math algorithms that it uses under the covers, that we won't go into the depth, but some of them are logistic regression or k-nearest neighbor, and maybe that could be something we dive deeper into in some of the future talks. So then I also, through this journey, realized, well, in order to prove that the model works well, I'm going to have to build one, right? Like, it's not just going to happen. And there's a lot of free data sets and easy ways that you can build one on your own. And often you can use data sets and data that people already provided, but I really wanted to start from scratch and create my own data set so that I can really see it truly end to end. So I had to figure out how to build a classification model as a result. So in this case, the steps I went through is determine what kind of classification model I'm building, then collect the data, then process the data and like narrow it down to what data I'm actually going to use for training and testing, and then I had to train the model and label the data, and then I finally was at the step that I was trying to be at, which is to evaluate the model. So my problem definition, just because that's the data set, and again, keeping with the swamp theme, is that that's what I decided to do, is build a model that classifies mushrooms in South Carolina. And that's something that could be used in a mobile app. It's not a real business problem. And in the real world, you probably wouldn't go it exactly in the order that I went. Usually you would have a business problem, and then you would try to figure out if classification is the right tool for the job. But in this case, I was specifically looking for a classification problem, so I sort of came up with a problem that fit the bill. So data collection. So in my case, I had a bunch of images of mushrooms, and when you go and gather all your data, regardless of what data you're collecting, you're going to have to really collect a bunch of data. And it could be, in the case of mushrooms, but you can apply it to anything else, is that you're going to have to get maybe varied angles. Maybe an old mushroom looks different than a young mushroom. Maybe in different lighting, it looks different. Maybe they grow a little bit differently in different areas. So there's a lot of biodiversity there. So in order to really build a good model, I didn't also want to build a crappy model. I wanted to build like a model that works relatively well. So that's something you want to do. And so you have to be careful about biases when you do that, where maybe if you only build a model based on things that occur in your backyard, maybe that's not going to be the most popular app out there. So once you have all this data, you then decide, what out of this data am I going to use for my training and then testing data? Typically, let's say I have 100 images total that I want to train on. I would use 80 of them for training and 20 of them for testing. And in my case, I just hand selected them, but you could use different techniques to maybe avoid some biases, such as k-means clustering, and that's a topic we could also go much deeper into, and I think we will in a few weeks. So just giving you some terms for the future to explore. So then when you go and do your model training, you have to label all your images in order to train the model. And so in my case, I named the mushrooms on the left morel and the mushrooms on the right lion's mane. But I was the only person labeling the data. And you can see that if there were, let's say, 10 of us labeling the data, there could be introduced biases such as different people label it differently, and also different people with different knowledge of the domain could end up labeling differently. So somebody who has no idea could be like, brown mushroom, and on the right, white mushroom. So that wouldn't necessarily be very helpful. It could be something, but you could even use Latin names. So consistency would be key at this step. And so you want to know what goes into all that. So then at the end, finally, we're at the step where we're evaluating the model. Is this actually good? Does it work as I would expect, or does it not work? And you want to provide some sort of a proof that it actually works. So if I give it this image, if I take a picture of it and say classify it, and this mushroom looks very different than the other ones, if this one is like bleeding or something, so If it tells me it's a morel, which morel, if you don't know, it's a very rare mushroom that doesn't grow that much, and it's a very expensive mushroom, and it's a delicacy. So if you were to buy it at a restaurant, you'd pay like a bunch of money, but you can just also find it in the woods. But also, if you were to pick and collect this mushroom, like this one's not that edible, so we don't want to misclassify it, essentially. So if I'm evaluating a model, I wanted to talk about like what are the types of things that I want to look out for as I'm evaluating a model, and I wanted to talk about it in more, business terms at a high level before I dive into the technical topics. So I want to make sure it works well with unseen data. So if it has not seen a mushroom yet, I don't want it to classify a mushroom that's like edible, and it just misclassifies it, and then you're going to eat it, and you're going to go into the hospital, and then you're going to sue me that I poisoned you. Like, we don't want that kind of stuff to happen. So we want to make sure it works well in those scenarios. Accuracy, that's similar, where if you find a mushroom that is the right mushroom, we want it to make sure it's classified correctly. We want to be able to explain why the mushrooms are being classified the way they are based on what features. And that, as Ted was talking about last week, can be important in highly regulated industries. So if you're working with manufacturing or healthcare, you need to be able to explain that the model does what it does and why that happens. You can't just say, oh, I don't know, I just put it in the black box and it came out seemingly right. That wouldn't necessarily work for auditors or people who regulate these sorts of industries. So scalability, so my mushroom app is clearly going to be extremely popular. There's going to be millions of users, so I want to make sure it doesn't like blow up, and there's going to be LinkedIn posts all over the place saying, mushroom app is down, I can't live my life, like what you've seen with ChatGPT. And then there's fairness and bias, so to consider, where because I'm the one responsible for the app, I want to be educated on the bias that could be potentially introduced and work towards reducing it. And in let's say the South Carolina mushroom example, there are 3,000 mushrooms. If my app only does like 10 of them, like maybe that's cool, but also don't want to make like absurd claims like this works perfectly. And I don't want it to be skewed towards just certain mushrooms. But at the same time, if I am transparent and tell you it only works for these 10, I think that's fine. So in this particular case, which is getting more into the nitty-gritty details at this point, is what are some of the metrics? What are some of the numbers that you're going to be looking at when you're evaluating whether your model works well? And in the case of classification models, the 3 common metrics that you look at are precision, recall, and F1 score. So precision is a measure of quality, recall, measure of quantity, and F1 score is the harmonic mean of accuracy and recall. And we'll go through each one of them in detail to find out what those are. But before we do that, so you think you're there always, and then you're like, well, wait a minute, I have to find out something else. So you have to look at the confusion matrix. And you have to look at all of your responses when you're testing, and you have to look at your predicted values and your actual values to determine how do I score my model, like whether it performs well. So the 4 different options are true positive, false negative, true negative. And there's an example that some people use when they're talking about it, and the example is there's a wolf or potential wolf, and there's a shepherd who's trying to guard sheep. And so if there's a wolf and the shepherd says it's a wolf, then the shepherd is a hero because the shepherd protects the sheep. So that's a true positive scenario. Like, I say there's a wolf, there's in fact a wolf, and that's a true positive. The false positive is that the actual case is there's no wolf, but the predictive is that there is a wolf. So the shepherd says there's a wolf and there's no wolf. So he becomes like the shepherd who cried wolf sort of thing, and it's like everybody's like, we don't care what you have to say. And then you can go through the other scenarios like that where true negative would be shepherd says there's no wolf and there's not actually a wolf, so that's a true negative, it's truly negative. And then false negative would be there's that's why it's a confusion matrix, because it's kind of confusing. So the actual, if it's actual is positive and the predicted is negative, then it's a false negative. But you have to, sometimes you have to go through it like a bunch of times in order to do that.
Sorry to break your flow. Actually, call.
So in the case of the mushrooms, in my case, the true positive, let's say this is an example, hypothetical, where they were, in order to calculate precision, you have to take the number of true positives and divide it by the true positives plus the false positives. So in my case, I had 2 true positives and 0 false positives. False positive would be that people thought it was that kind of mushroom and it wasn't. So my precision score is 1. It's great. So it's 1 would be 100%. So in this particular case, precision is very good. And then recall example would be just like sort of in a human brain, how many like things can you recall correctly? So in this case, you have to take number of true positives and true positive plus false negative. So in my case, it ended up being 2/3. So 67% roughly. And then F1 score, it's a blend of the two. So in my case, the F1 score ended up being 0.8%. And certainly we're talking about mushrooms here, but you could look at things like a COVID test. A COVID test is either positive or negative. And you can start thinking of it that way, where what if I got a true negative COVID test? The test said I didn't have COVID, and I did not, in fact, have COVID, so that's good. But I could get a false positive where it says I have COVID, but I, in fact, don't, so that could be problematic. And you can take it to all sorts of potentially illnesses like cancer, things like that. So you always want to balance and look at these scores to find out how well your model is doing. Because you don't want to set necessarily the world into panic. So in my particular case, and there's a lot of numbers here, but how well did my model actually do? So there's all sorts of numbers here. So the precision, recall, F1 score, and then what I wanted to highlight in this particular case is so if you go to the, okay. So one of the mushrooms, the wood ear, ended up having very low precision score, and as a result, very low F1 score. So that means that's something to look into further, where you can look into things like, did I provide the right training set? What do I need to do? I need to optimize it. I may not be able to release it, or do I just release my app without this amazing mushroom present in it? You have some decisions to make. And certainly you can even you can go through every single line there and try and figure it out. So things I could do to improve the model are improve my data set, so add more images for some of the mushrooms that did poorly, maybe different angles, or trying to figure out what happened there. And there's certainly techniques that could help me, such as when we're improving the selection of training versus testing data. We talked about the k-means clustering that could help give you a more diverse, better data set. You can work to eliminate biases where you all of a sudden don't just cover 7 mushrooms and focus on those, but you do a bunch more. You can increase variety of training images. And there's also lots of other things you could do. So one of the things that could be a topic for another meetup to go in depth on is cross-validation, where you're really, that's a technique you use to see how well your model generalizes to new data. And so in my case of 100 images, I had the 20 reserved for testing. But if I were to slice those 100 into 5 groups of 20, I would always be changing. I would run the test 5 times, and each time my testing data would be different. So that way I run the test 5 times, compare the numbers, and see how well my model performs, and that could lead to more discoveries and more things that I could do to make it better. And so in summary, what we at a high level talked about is classification, building a classification model, and then evaluating a classification model. And you sort of have a manual on how you can do that on your own if you wanted to find that out. And that's it. The end.
Oh, everybody's looking at me. Oh, you know, it's kind of Lucie's show still. Are there any questions? If you have.
So I started to look at using Azure. So Azure is Microsoft's cloud to do that. And that wasn't working quite right. So ended up finding, like on Amazon, there's a Recognition or Recognize, I can't remember their names, something like that. So there's an AWS tool that can help me do that. But there are other free tools that you can, I think,
Oh, I mean, like from my perspective, there's a ton of classification models are great, right? There's a ton of really cool tools. Google has some stuff out of the box. Probably if you guys really want to get into classification, I personally recommend like the TensorFlow tutorial,
yeah.
which is in like a Jupyter notebook. You don't have to install anything. But if you just type in like TensorFlow first tutorial, deep learning into Google, I'll share some links on this. Just so you guys know, we'll share links and stuff for the questions. I'll share this on like the Discord and also on like our website, so you'll be able to find it. But that it's such a great deep learning tutorial. I know that sounds sort of silly because like the first one you do, but it's actually like really good. So I highly recommend any of those tools. Like you used Amazon, right?
Yeah.
I think Amazon
Recognition, I think, Recognize.
Fantastic.
Amazon is going to like chase me down for not remembering their names.
Where's Carter Edmonds, right?
Yeah, where's Carter?
Where's the AWS? Shout out Carter, who runs the Amazon user group here in Columbia. Like, he can probably answer our question.
So, how's your learning curve on this? Massive? Not too hard at all? And if you did it again, what do you think your time frame would be to produce it? Not this, but similar.
Just so you guys know, like, because I'm just like repeating your question for the recording. George asked a great question, which was like, what was your learning curve on this? And if you were to do this again and relearn this stuff, like maybe what would you maybe do differently?
So I feel like it's a little bit hard to answer because I've learned it over time. But let's say if you're going into it with knowing nothing, your curve could be different than mine. I feel like it's such a personal thing based on people's knowledge. So for me, it wasn't that bad. I mean, but there's still a lot more that I could learn.
What if he brought you a classification problem? He had a classification problem. You work on how usable would techniques
So I think what this highlights is that you do have to have deep domain knowledge on some of these things. And that's what Ted highlighted in the talk last week, where sometimes you have to like learn about it for a year in order to actually be able to do it. So and that's why I think the mushroom thing, even though it's sort of like nerdy or whatever, it's sort of interesting because if you look at the mushroom, you're not going to see the same thing that I see. And it's the same where if you have, George, like deep knowledge into some area and you're going to bring it to me, I may just ask like really dumb questions because I don't know anything. So my learning curve may be more on the domain and less on the technique.
To give you some background on like my experience, a lot of the stuff that I learned, that I use today for like the deep learning, well, even just for machine learning, right? 4 weeks, right? Like that was, I essentially went to a program where 8 hours a day with machine learning faculty members, you know, basically like 10 hours a day for 4 weeks straight, right? And we already know how to code. Right? But I still use a lot of what I learned in that very intense like period of time, still highly relevant. So that's why it's kind of like a hard question, I think, for everybody to answer, right? Because a lot of this stuff, like the deep learning stuff, I learned later, and I learned it kind of when I needed it, and kind of. But the actual like the thing that started me on my machine learning journey was essentially 4 weeks of an intense boot camp. Whereas I think other people, like, you know, it's probably like you knew how to code, you had some exposure to this,
Right.
you did a couple problems. So it's hard to say, like, it can be very short if you need it to be. I think you'd be surprised at how quickly you can, I think, learn this stuff, because in my mind, it's very intuitive, right? You know, you're doing a classifier. Like, I want this thing, it's designed to work the way humans work in a lot of ways. So especially with deep learning, I think there's a good intuition. If you're like, oh, I don't understand how I would even tell the difference between it, probably neither will it. Right?
Right.
Like if you look at like two flowers and you're like, I don't know, they look like they're both the same to me. That may be very well the answer. So I think it is like it's a highly dependent question in my opinion.
At the same time, I think you can go to places like Amazon or Azure or TensorFlow and use some of their pre-built data set and just run the results and get the numbers. It just may not, so you can choose sort of the less intense way of learning it versus I chose the more potentially harder path with providing my own data set. But at the same time, there's nobody stopping you from like going around your house and taking pictures of just everyday objects that you're very familiar with and just seeing how that would work.
Yeah, what's the famous like example of the hot dog, not hot dog classifier? There's some really cool like dumb stuff out there that's like kind of fun. It's surprisingly difficult problem, and the guy tried to like add tacos to it and it just falls apart. Any other questions?
Yeah, so I think a lot of these techniques that we've been discussing would make a lot of sense for closed-ended machine learning problems, right? Where kind of the output of your model is like yes or no, or you know this type of object is present in this image, something like that, right? So I'm curious to know what types of techniques would you use to evaluate model performance in like a more open-ended problem? I mean, obviously the big hot topic is language models and Gen AI and stuff. But I don't want to be constrained to, you know, just those. I think there's a lot of different machine learning related and adjacent problems where you might have an open-ended output, right? Where you can't necessarily say my output is always guaranteed to be true or false or something. How would you go about evaluating those types of models?
So that's a really good question, because the way I interpret the question is, let's say I look at DALL-E or something that generates new images based on images that I've seen before. How do I test that? How do I test that the image that was created based on images it learned about is correct? And we know Google had a little problem with some of their testing earlier this year. And the answer is, I don't quite know how they test it. They have to have some sort of testing, but I don't actually know. So that would be something that I would have to look into. Maybe Tad knows, but so that's why I started with something a little bit simpler, because I think in some cases, the way I think about it, and I could be wrong, is that you have to sort of understand some of the simple stuff that's maybe not as cool and maybe like a little more boring in order to be able to understand some of the more complex stuff that's like cool.
Any other questions? Yana?
And then,
Just I'll hold it here.
all right, cool. um, and then when you had your final list, you had classified something like 6 or 7 mushroom types.
Mhm.
Does the confusion matrix expand across 6, 7 categories? And then how do the recall F1, how do those parameters change when you expand it to multiple classes?
So based on my understanding, you always do it from the perspective of the single class. So you look at the one class and you see how well it worked for that class. And certainly the other classes play a role, because, so the way it works, I'll just sort of explain how it works. So you have, let's say you have 20 testing images, and you run the test, and some of them are going to be classified as one class versus another class, etc. And then you're going to count up how many of those you got wrong. So first you label your testing set. So you are expecting, let's say, I'm trying to figure out how to make it simple math. So you have 10 testing data, and you have 2 testing images each. You have 5 classes, 10 images total, 2 each. So then you are expecting like 2 lion's mane, 2 morels, 2 chanterelles, 2 wood ear, and 2, like another type of mushroom or oyster. But then you run the model through the test, and your results come back that there are in fact 3 lion's mane. So that's what the model thinks. The model is telling you, I think that there are in fact 3 lion's mane. And I think there are 3 chanterelles, but you know that there aren't. So it just means that the model didn't learn that well. So you look at all those numbers and figure out which ones it got wrong. So in this case, it got one of the, you always get a confidence score as well when you get the result. So it's going to tell you, 80% confident that this is a lion's mane on this picture. And on this picture, I'm 50% confident that it's a lion's mane. And on this picture, I'm 30% confident it's a lion's mane. And then when you are testing, you set your confidence threshold, where you say, depending on how confident you are, I'm going to figure out if it's a true positive, false negative, etc. So if you tell me, I am really, really confident that this is lion's mane, and you're correct, it's a true positive. If you tell me this is a lion's mane, but you're only 10% confident, it's going to be a negative, because you weren't really confident. Like, you guessed it right, but you weren't confident. And then if you confidently tell me this is an oyster and it's not, then you're just completely wrong. And so all of these play a role. And so you have to count up the numbers and figure that out. So, and then when you look at all that, you look at 4 lion's mane, you say, the model confidently told me that 3 images were lion's mane, but 1 was wrong. So all of a sudden I have my numbers. But I don't, it gets, and I do understand why they call it a confusion matrix, because like, I feel like you have to just go through it to like truly grasp some of that stuff. And like go through the exercise of figuring out what some of that stuff is. Because if you just look at it, I don't think you can fully grasp it, or maybe you can. In my case, the way my brain works is I have to like really go through it and truly understand it.
Yeah, go for it, man.
Hey, so with the cross-validation process, what do you think is like the best way to determine the best testing strategy? So like K-fold, holdout stuff, and many others I'm probably forgetting right now. How is there like a good way to determine what's the best for that situation, or just kind of throw as much as you can at it and see what's best?
I don't think you necessarily have to throw as much as you can on it. I mean, you definitely have to have a good. The hardest problem is always getting the data set. So you always have to start out with like having really good. So that's where it always starts, and that's the hardest part of it all. And then by the end of it, there may be techniques. I'm not quite yet familiar, but there may be techniques on like how to figure out. I mean, I think maybe you would just run for cross validation. You would just run like k-means clustering the first time to determine what's your 20%, what's your 80%, and there may be a way to sort of slice up the other 80% into 4 pieces so that it's always different, and then run it. I think it sort of starts at the front when you're determining the training and testing data. So that's where k-means clustering would give you the proportions, and then you really just run it through the test and determine like, are you getting consistent results or no, based on the numbers you're getting.
Kind of interested in your sort of medical testing you had worked with. Yeah. Just from the standpoint of, do you try all the methods and keep on experimenting?
I don't, but it's because like I'm right. I always feel like. Oh yeah, you're right. So the question was like, from my experience, no, I don't. I'm good. I'm absolutely golden over here.
You want to be evaluated?
No, yeah, no, I did my time last week. the question was in my experience in stuff like medical devices, where in my industry where we did a lot of machine learning, for my department, like how would we have done this? Would we have just tried all of them? And the answer is, it depends. For a lot of stuff, I think, look, if the F1 score is good, I'm going home. Right? We did it, we ran it, we tried, I've got a number, and for like low value stuff. Really where I start throwing the kitchen sink at it is when we start getting bad numbers, right? Because now I'm trying to get a better understanding of the data, right? Like if I do the thing and I crush an F1 score on like my first try, I feel like I've got a pretty good handle on this one, right? But if I do it and I get a garbage one, now I need to get a better understanding. And so like, let's say, I think you kind of touched on one example, like, all right, I've done like my confusion matrix, which gives me some idea of where the weaknesses are in my data. I might go through, I use a lot of time series data historically. I might do a leave one out cross-validation. And the reasons for that is I'm trying to find what is the thing that's influencing this the most, right? So now I'm using that style, but that's because I want to, like exactly what you touched on, that's because I think it's upfront. I think the problem is with the data, and I'm trying to figure out where in the data are we getting this. I might do residual analysis if it's like where I'm trying to basically just see what's the difference between what the model predicts and how big the gap is, if I have like a magnitude. If it's a classification thing like this, I mean, yeah, you're doing your confusion matrix, you're doing your F1 score, maybe I leave one out. If it's a classification model that allows me to use a more interpretable model, like it's not images, for example, then I'll almost always throw everything through a random forest, right? And look at the importance. So yeah, it's basically highly dependent on like how important is this data, how much are we struggling getting a handle on this, how well do we understand the domain, right? Some of these things, I would get dropped data and I'd be like, what is this? For example, we had a data set that was quite large in our company that had been designed by a German, and so all the column names were in German. And I don't speak German. And yeah. And so there's 100 column names, and so you couldn't even develop intuition over that data set for non-German speakers. So I hate for the answer to always be like, well, it depends on what you're doing, but I hope did that give you some context, like where you would dig in and stuff? This is a really rich field. I hit it because I think there's also a lot of stuff you can do in here. And maybe there's later talks like on validation involving like imaging the data, like looking at how the data is distributed and seeing where you start to see residual analysis on that. Your question for like open-ended stuff, right? You know, there's a lot of what does cross-validation mean if you use like a more open-ended model, say like a recurrent neural network? I don't know, right? Because you're only looking at how good the model is at this point in time. The model's always changing, right? So I think there's some really cool. This opens up in a lot of ways some really cool like other talks maybe you dive into or places to look or really cool like thoughts to have. So I think it's a really fun topic because I know it doesn't seem like oh how well did your model work, but this is to me like the heart and soul of it. Like actually getting the models to run is whatever, right? But getting them to like give you some level of trust, interpretability. That to me, and this was the talk last week, that's what data science really becomes about, right? Is being in that loop. And so I think this is like the stuff that nobody wants to talk about, and it's like incredibly important. So I think Lucie picked a great one. I'm talking too much. That's my specialty.
The one thing, like from like the way I picture some of this is that, so as Ted touched on it, this is a vast field. So imagine it's just like mushrooms. There's thousands of options there. Or let's say you're building a house. There's all sorts of tools you could use, and you just have to pick the right tool based on the job. But if you don't know what the tools are, how will you know what to use? So you take a hammer to wash your car, probably not going to end very well.
Yeah. Are we ending on the hammer?
I'll do business questions.
Okay.
And so maybe you could speak to this because I know you mentioned that you've been working in like document classification in your professional role. So I'm curious. I know in a lot, depending on your specific application area, you may care a lot more about false positives or false negatives. For example, if you're a bank and you're going, I want to classify fraud score for this transaction, right? If you have a false positive and your anti-fraud have to go look into it, but it wasn't really fraud, right? And it's not really a big deal. You wait some time, but like nothing bad happened. But if there's a false negative, right? Something that was fraud that's true, right? That's really bad, right? And of course, in different business domains, you may care more about either the false positive case or false negative case. And so, how what kind of tools are you using to think about that and discuss that with your team and kind of quantify what approach is right, what are the business risks, what's the monetary upside, downside, stuff like that. Right? Like when I go to my boss and I'm going, I want to implement this model for this business process, he's going to go, okay, well, what's our best case for how much money it's going to make? What's our worst case for how much money it's going to lose? What's our expected case, right? So I don't work with this stuff on a day-to-day basis in my job. So like, how are you guys like actually thinking about and approaching that aspect of it?
So I do think you have to, as you touched on it, have to really understand the domain you're in. And let's say in the fraud case, maybe there's just some finances there, but it can still potentially like mess up somebody's life. So maybe you still want to take it like a bit seriously. You don't want to freeze their account and accuse them of terrorism when they didn't do anything. But then there's things like medical stuff where let's say you use AI tools to try and figure out does this look like cancer or not? Maybe in that case you say, I'd rather have false positive than to under quantify, where you say you're good to go when in fact you actually have cancer and you may need to do some treatment. So you have to really, I think, you have to look at, if we get this wrong, what's the worst case scenario? And if we get this right, what's the worst case scenario? And really think through that. was during COVID, and I was talking to one of the guys, Marty is his name, and he said, like right now, what's actually happening is we actually have calls being directed from the suicide hotline into our domestic violence hotline, and we can only take 60%, 70% of the calls. So a lot of people are not getting the help they need. But also what he highlighted that if you get some of the stuff wrong, what can really go wrong in these scenarios if you don't get the calls? Some people can like die, or if you, in the case where, if you don't keep the people anonymous in that particular business scenario, what can happen is that cops show up at the house because you're obligated to report it, and they can die. So you really want to be careful with that sort of stuff. So it just really depends on the sort of problem, versus if it's like, well, I mean, honestly, it's the same with mushrooms. Like, you don't want to misclassify it and then like you eat a mushroom and you die. So then you just have to keep track of it, like try and avoid the worst case scenarios as much as you can. But also sometimes there's cost involved in preventing the worst case scenario. So you just always have to balance all that.
The cool thing also to think about in some of these models is like how the model is structured. Like, so for deep neural networks, remember that while you may have a classifier that's a binary output, it's picking me up on the webcam. I'm just being projecting now. You can pick it up as a binary classifier, but the number that comes out of it is not 0 or 1, right? It's a continuous variable. And so one of the things we've been able to do, like in my experience, is, oh, you're getting usually a value between 0 and 1, you know, 1 being definitely like if you're doing dog cat classification, or mushroom will kill you, mushroom won't kill you, right? You know, 1 is 1, and so it's giving you the probability of the things, right? And what we would actually do is look at like our acceptable, and you do a risk analysis, and we kind of what you touched on before, like almost a cost benefit analysis, and determine like the classifier natively sets the value at 50, you know, at 0.5, right in the middle. But I might say like, look, I really need this thing. I'd rather have a lot of false negatives than false positives. I'm setting it at, if it's not 0.95 confident, right? So I can move that threshold based on like my appetite for risk, as it were, right? And you can actually fill that out as a, you can actually validate these things, in my opinion. I mean, we've done some of this. I've gotten some kickback. You can validate these things, in my opinion, as a measurement system, as you would a classic measurement system through a typical risk analysis process, including doing gauge R&R studies for how well it measures.
But then let's say, Tad, you then reported to your boss who may know nothing about the technical stuff, so then you say, you know, like worst case scenario, like I'm trying to think through how like—
See, I was in medical, people die all the time. You're like, oh, worst case scenario, somebody died. They were using the product because they were sick, right? Some people don't make it. what are you gonna do? You know? Yeah, it's hard, right? But I think for me in manufacturing space that I'm in, being able to show that we get this continuous output was huge.
Okay.
Right? Because they're thinking like, oh, we're used to qualifying measurement in the production, whatever it is, whether it's, you know, literally measuring with a ruler. We have a process for that. And I go, look, forget about what this thing does in the background. You don't know how your laser measurement gauge works either, right? You know, but you know how to check it, right? Validation is what you know. I can give you the same validation numbers. And I think what you're talking about here touches on that, right? That even if you don't know what the model's doing, there are ways to validate that it is doing it well, that it is doing it in the way that is expected, that the outputs are what you want. And I think that's a good way to an extent, manage risk and knowledge and, you know, what you want to do with it. It's really cool stuff in that field. Like, why it's such a great time. All right, is that it for questions? And that's it. We'll see you time. I don't know how well the microphone's ringing. I'm going to make a couple of announcements.
Okay, I'll not fall down.
I would have offered you an answer. You crush it. Couple of announcements. Thursdays, once a month. I think the next one's on the 27th. Kevin Schumacher does Carolina Connect AI Lunch and Learn. It's at the Expansive. It's at 11 o'clock, I'm pretty sure. But look, 11:30 for the people that know. 11:30. It's great. It's more introductory, but it goes through like ChatGPT stuff. There is a conference that I was asked to mention. There's a conference going on in August 22nd. I think the organizer is going to reach out to us directly, called, and I had it right here, and then I closed the screen. There's a conference going on called the Carolina Codes Conference. It'll be August 23rd and 24th in Greenville, South Carolina on 701 Poinsett Highway. You can find information about this at blog.carolina.codes.com. I'll leave a link on the website. Julie, are you doing another presentation this week? Because you held out on us last time. Julie spoke. Julie gave a whole AI thing. Didn't tell us. We didn't get to announce it. Are you doing another one?
So the National Black AI Literacy Week is going on. It started on Sunday. I spoke on Tuesday. Thank you, Lucy. It is on YouTube. My talk. You don't know who I am. Hey, my name is Julie, and I'm the only AI certified social worker in the United States, possibly in the world. My goal is that when people think of AI literacy in South Carolina, they think of me. And so my talk is called AI for the Rest of Us, Practical Tips on Using AI Tools. That's what I talked about. Do I have another one? No. Am I doing a workshop on how to? No, yet we didn't sign up on our website. Fred just said that it's a technical talk. I am not a technical person.
The person who gave an AI talk on Tuesday is the not technical person.
I am not a technical person. You want to learn how to make a t-shirt using AI images and also keep your intellectual property and do a print on demand website so you can make some money? Then you can talk to me. But if you want to talk about classification and large language models and the technical stuff,
So if Julie had, when Julie is at social expat YouTube.
Socialworkexpat.com.
Yep.
And my SWOR mentor said that doesn't sound like AI, so it's also AI Builders Connection. My last name is Nickel, like the only president who impeached and left office. So there is connections in there.
And George runs the blockchain cryptocurrency Friday Zoom call. So if you want to get in on that, that's the man right there. Like, no, we want to promote all the tech stuff happening in South Carolina. I think we hit all the ones we know about so far. There will be more, hopefully, with Silicon Swamp. We want this to be the place to nexus all that.
So see you next week for Tech Hops, and then in 2 weeks.
Right. So next week I'll be here, but we won't be doing this because it'll be Tech Ops with free beer. So in some ways, win-win. But the week after that, Yana is going to talk to us about the research she's done on eye tracking, which is what I announced last week, but I was incorrect. This time I'm right. So 2 weeks from now, Yana's going to give us a fantastic talk about that. Her research that she did her master's thesis on and learned, and then recently shared with people all over the world in Alaska. Tell us all about that. So if you want to, like I said, if you want to talk, let me know. We'll figure it out. I mean, we're excited for everybody. I think that's it for announcements. Let us know any feedback you have. We're thinking about adding food to this equation. We're thinking about doing it this week, but let us know. Yeah, okay. So it seems like that's popular. What you're thinking, what your thoughts are on the food situation, drinks. We get some coolers in here with some Diet Coke and make this happen in a spot. All right, that's it, guys. We continue networking, as Carl said. So yeah, this just turned